It'll show in the corner of the screen.
Now we're live.
Okay, it looks like we are live. Okay, wonderful. And everyone, and you can hear me, hopefully. All right. All right, thank you everybody for joining us today. It's really good to be invited here to Expanding Your Horizons. It's really good to be here. Thank you, WSU, for having us. We are with the Future Maker Lab. We are based at WSU Tech, which is the local Wichita, one of the local Wichita technical colleges, and we're based here. And normally, you've probably seen us around town here and there. We're a really big truck and trailer combo, and we go to a whole bunch of middle and high schools all over the state, getting students interested in career and technical education pathways. And we also go to different STEM-related activities in town, like we were at Riverfest, and we were at the live Expanding Your Horizons before, and we've done all kinds of different things. STEM standing for science, technology, engineering, and math. So if you hear that term, that's what STEM means. And so that's what we do here. But we are coming to you today. Obviously, we cannot come to anyone in person because of these circumstances. So we have built a digital content lab since the beginning of the pandemic here at WSU Tech. Have been so kind as to let us use this room so that we can bring all of the content that we show you to you at home or wherever you're joining us from. And so that's what we're going to be doing today, is showing you this from our digital lab. So what we're looking at is advanced manufacturing. We're going to be looking at both the additive side and the subtractive side of advanced manufacturing. Additive being 3D printing, subtractive being CNC machinery. And I have two co-hosts with me today. I don't think I introduced myself. My name is Lauren. And then we've also got Noah, who's going to be talking about the 3D printer and demonstrating that. And because we are practicing social distancing, we will not all three be on stage or in front of the camera at once. We will have masks on at all times. And so I'll go ahead and let Noah come on and introduce himself.
Hello everybody, my name is Noah. Today I'm going to be talking to you about our additive manufacturing techniques using our machine here called a 3D printer. We're going to have lots of fun and I hope you guys are going to learn everything. So please ask questions whenever you're confused and I'll have our next co-presenter come on stage.
Sure. Yeah, go ahead.
Awesome, thank you, Noah. Well, my name is Levi, and I'm going to be showing you the subtractive manufacturing side of what we're doing here. It's a lot different than the additive side. It's going to be really fun. Looking forward to it.
All right, thank you guys. We'll get right into it here in just a second. Just wanted to remind you of a couple of things. I'm not sure if this is applicable anymore because of the Zoom presence, but I was preparing to tell you guys to make sure and keep your mics on mute and everything so that we don't end up with any noise, but that might not be relevant anymore. I'm not sure. But also a big thing that's important is to make sure that if anyone does have access to these kinds of machines at home, it is important that you have grown-up supervision and not to try anything that you might see here today without being supervised, because these can be dangerous if not used properly. And also, I do think that we're going to have our questions fielded for us. I'm going to look over here real fast. Okay, looks like we're good. Looks like we're going to have questions fielded by our moderators that are go up in the chat box. However, we will be answering questions during the presentation as well as afterwards. So there'll be plenty of time for that. So I will go ahead and let Noah take it away with our Dremel 3D printer part of the demonstration. So go ahead, Noah.
All right, thank you very much, Lauren.
Let me go ahead and put this down for you a little bit.
Right.
There you go.
Okay, thank you very much. So today we're going to start off by talking about the first piece of our additive manufacturing technique, and that's going to be additive manufacturing. Now, how this works, it's like if we start with nothing in our workspace, and we're going to put pieces together or put material together to create a functioning 3D object. Now, a great example that I like, has anybody here played with Legos? I know I have. It's been kind of an addiction of mine ever since I was a kid. But they kind of work in a similar way. When you get a Lego set, you start with a bunch of material, but you overall have nothing put together. And you put together these little Lego pieces on top of each other, stacking them together, putting them together until you have something like a spaceship or a rocket or a house. And that's kind of the same idea with a 3D printer. So we're going to go ahead and go to camera 2, and we're going to show you kind of in depth how this 3D printer is going to work. So this is our Dremel 3D40 3D printer. I'm gonna go ahead and open the door. And how this works, it starts with our base material. Now, the most common material in a 3D printer is something called plastic filament, and that's what this is right here. This one's a red, and it's all spooled together on the spool, and it just looks like this small little strand of plastic. So, as you can see on this printer, we're actually using yellow plastic filament on the side over here, and it's being fed through our 3D printer into what we call the extruder block. Now, the extruder block is this big black piece of plastic and metal in the right-hand corner of my printer. Now, on the bottom of this block, and it's actually kind of hard to see, there's this tiny, tiny, tiny little nozzle. And what's going to happen, that nozzle is going to be heated with electricity to about 200 degrees Celsius. So very hot, you don't want to touch it, it will burn your skin. But 200 degrees Celsius is actually hot enough to begin melting that plastic filament up there. And what it's going to do, it's going to move a motor back and forth to the correct spot on this build plate, and it's going to basically squirt out just a little bit of that melted plastic and basically just glue it onto the bed on a specific spot. So how it does this, it has a series of gears, pulleys, and motors that allow me to move this print head back and forth in all 3 dimensions, hence a 3D printer. So this right here is the x-axis, more commonly known as our left or right or side-to-side axis. We also have the y-axis, which is our forward and backwards. So I could bring the print head forward or I could push it back. And our last axis, called the z-axis, or up and down, is actually controlled by our build plate right here. So when the 3D printer starts, it's going to put the extruder somewhere in the middle, and it's going to raise this print bread all the way up to the nozzle. So like about right there. Then this extruder head is going to move left or right, or back and forth across the build plate while it's squirting out some of that little plastic, and it's eventually going to build pieces up on top of each other. So right here, I have a quick result of something that's been 3D printed. And this right here is a picture, a little bust of Darth Vader from Star Wars, of course. And it's been just layered on each other with the exact same type of plastic on this printer. And we have some other examples. Oh, I turned it off accidentally. Let's not do that. So that's the basics of how a 3D printer works like. So let's go ahead and go back to camera 1 for me, Greg. Now, the whole idea and process of a 3D printer is part of something called the engineering design process and the idea of rapid prototyping. So we're going to use a 3D printer to create 3D objects, but we need to start with a mission or a goal when we're creating 3D objects. And that's basically our main idea, or the reason that we're creating an object. Say we see something in the world that we feel like could be made or could be improved on. Say there's a car part, a broken car part, or something in your house that you're like, hey, I might be able to create something to help me with that. Like a coat hanger is a pretty big common example of that. Or if we need to replace a part that's been made by somebody else but has broken or replaced and we can't buy or replace it without using a 3D printer. So today we kind of have an example issue that's going to be solved by our 3D printers right here. And I'm actually going to get Levi over here to come on and tell you guys about it.
Awesome, thank you, Noah. So, I'm a guitar player. I play guitar in a college show choir. Now, every show week we have 4 shows. This time we actually made it through 2 shows, and this knob right here actually fell off. There's supposed to be 2 of these, and it broke into a bunch of little pieces, and one of the dancers stepped on it. I still need this guitar for 2 more days, but I can't use it without another volume knob. Is there a way that we can fix this with 3D printing?
Thank you very much, Levi. And there is a way that we can fix this using 3D printing and additive manufacturing. So we're going to start with our main idea, which is to create a replacement knob for Levi's guitar. We're going to start by issuing that idea and recreating it in a piece of software called CAD, which stands for Computer Aided Design. And we're actually going to go ahead and switch to our live share screen to show you guys what a piece of CAD software looks like. We're going to go ahead and get it set up. And that tab right there, perfect. So this right here is a piece of software called Tinkercad. And it's actually running on like a regular web browser that you guys could also access on your computers at home. So if you ever wanted to mess around with the CAD software, you can do this on your own computers at home by going to tinkercad.com. Just like that in the corner, you can create a free account and you can get started basically making whatever your mind comes up with. And again, anything you think about, anything you imagine can be created using a CAD software like this. So the basics of a CAD software, we're going to go over this real quick, is that we have a work plane in 3D space and on our computer where we can digitally create and alter items in our 3D space. So there's always going to be a few presets on Tinkercad that we can, just drag and drop over. So I can take in this box and I can put it wherever I want. And I can actually alter this box to my heart's content. I can resize it, make it skinny or wide or long, make it even taller or shorter. Oops. So you can alter any object, or you can create objects from scratch using this piece of software, again, called Computer Aided Design. So you might notice I've actually already recreated an exact 3D copy of Levi's guitar knob right here. So this is actually, whoops, whoa, way too far, getting way ahead of myself. This is actually the tone knob for Levi's guitar, so we've labeled the tone on the top. We've given us some nice grooves here so we can get some good grip for quick adjustments on the fly. And we've also labeled numbers 1 through 10 on the side so we can get quick, precise adjustments to the tone of Levi's guitar. So this process can take anywhere from a few hours to a few days or even weeks. You can really nitpick on every little designed piece of this guitar knob or anything else that you're creating in 3D virtual workspaces. So because this one's pretty simple, we went ahead and just recreate it on the fly, so we're not, spending hours up here watching you guys, watching me work on this. So once we think we have a pretty good design, what we're going to do is we're going to prepare this 3D model for our 3D printers. And we're going to switch to a different piece of software. This is called a slicer. Now what a slicer does, it's very similar to CAD. You can see I have a similar looking workspace and I have the exact same object here. But instead of creating objects from scratch, we're going to basically translate the existing 3D shapes into something that a 3D printer can understand and create from scratch. So this is what the computer says our little tone knob is going to look like after we 3D print it. And I want you to notice, if we really zoom in here, you can see everything looks like these little tubes that are going around. That's the actual 3D filament that's coming off of the 3D printer. That's kind of the shape and kind of texture of how our 3D printed object is going to look like. And I can actually cut through each layer of this part. You can see each of these layers is going to be created by our 3D printer. So here's the first layer, and it's going to build up on each other all the way up to the top to create our tone knob. Now there's a few settings we can change in our 3D slicer up on this right side. The first one, and arguably the most important one, is the quality known as the layer height. So right now we have a very low layer height. Think of this as like the resolution of our 3D printed object. The smaller our layer height is, the more detailed it's going to be in our model. If I were to change this to something bigger, let's say 0.3 instead of 0.1, I'll go ahead and hit prepare. You can see this object looks a lot more chunky. There's a lot more thicker line. It doesn't have as much detail. Now, this would be good if we wanted to print something very fast, but if it doesn't need to look as good. But because we're creating an actual replacement part for Levi, we're going to go ahead and keep it at our higher resolution so it can look nice and fancy on this guitar. So there, this is what our 3D printer is going to take in and print. So we actually have a little time lapse that Greg can go ahead and show on video 1. That's going to show what a 3D printer actually looks like in motion. So this is creating the TRex head from scratch. It's starting at the very bottom and moving up. You can see each layer is built up on top of each other. And we're almost done. And this actually is sped up over 8 hours. It's a very long process for 3D printers. So that was an 8-hour print that we've just shortened down to about, what, 30 seconds. And you can see we're going to take it off the build plate. It's actually stuck on there pretty tight, so I'm just going to go ahead and rip it off. Just like that. And that is our TRex head that's been 3D printed from scratch. So let's go back to camera one, Greg. Perfect. So I've actually already created and 3D printed the knob for Levi's guitar in red right here. And he's going to go ahead and try it out. So I'm going to set it down right there for you.
All right, let's
See
see
if
if you
it's-
save my bacon. There we go.
Nice. Look at that.
That is awesome. Thank you.
That's awesome. That's kind of the inspirations behind 3D printers. Basically, using the design process, using what we think we can use to create 3D objects, translating that into a program that our 3D printer can go ahead and create, and we can really model it. We can test it in the real world. A good note is that with the design process, your first try, and even your second, third, fourth, and all the way up, usually isn't going to work very well. There's going to be small tweaks, small changes you can make to make your product or your art piece even better than before.
No, that is such cool information. We're
Yeah.
on board here for a few more minutes so we can go over a few more things. That is so neat. I really loved making the TRex head.
Yeah, you want to show it?
He was super fun. Yeah, I put this in with our other coworker on last Thursday, and I kept getting distracted at my desk because it was fun to watch him get made every now and then.
It's a
because
very cool process.
yeah.
All of this is controlled by computers.
Mhm.
So once I do just the steps I was showing, the CAD work and the slicer work, the computer inside the 3D printer does the job for you. I don't have to sit here and manually move the extruder back and forth. It's all done by the computer itself.
And of course, anything dinosaur related, I'm always into that. That's
Yeah.
I've always been a dinosaurs kid.
It's just
so.
really cool what you can do with this technology.
Yeah, it really is. Okay, so someone asked me how long it took to print. You know, I found the program in here on it's just already in there. If you hit a button and it looks like a T-Rex head and it'll make it. This one is programmed for 7.5 hours.
Mhm.
So
And it really depends on the shape of the object you're making and how detailed and how precise you want the object to be. That can decide how long it takes
Right.
for it to print. So something small, like this tiny little cat
Teeny
right
little
here,
cat.
I know it's really small. This probably only took like 30 minutes to print. But
Mhm.
something bigger, you know, if you compare sizes, the T-Rex head will take 8 hours, and there's prints out there that take days.
oh yeah, that's a few hours is nothing compared to how long certain things can get made with
Mhm.
3D printing. So we're going to show you a few more things over video that can get made with 3D printing, and we're going to start talking about all different kinds of things that you can do and letting your imagination go wild. So if anyone can think of things in your house, or if you can think of things that could be made that you would like to see made with 3D printing, everything from different, like your favorite kinds of toys to big things that you might not think could be possible. But as we're going to show you here in a second, there are lots of cool things that you can make with 3D printing. And my favorite part is that it can help a lot of people.
Mhm.
We're going to be looking at things like how you can build houses, how you can create medical equipment,
Mhm.
including things like anything on the body. Basically, I don't think I know they've tried a bunch of stuff, but they've done organs as like internal stuff as well as external stuff like prosthetic limbs,
Mhm.
which is really cool. I really do love that part. So
Yeah, it just shows how versatile 3D printing is, because most 3D printers, they're going to be using these thinner, more weak types of plastics that we've been using here today.
mhm.
But there's really no limit to the amount of materials that you can put into a 3D printer.
So anyone out there can feel free, if you have the access to, if you can think of what could be made, that can go up in that chat box. We'd love to hear everybody's ideas. But
Get some of
also
your
while
thoughts.
while you're thinking about that, we are going to have Noah. And I didn't introduce Greg. Greg is, when we're saying, hey, Greg, can you help us out with this? Greg is back there. He's our coordinator for Future Maker. He's back there doing all the controls and the computers and stuff, making sure that we're on the right camera.
Mhm.
And Shay, our fearless leader, is behind camera too. So my apologies on that. But yeah, Greg, can you take us back to the videos to show us all the other cool 3D printing
Yeah,
stuff?
video number 2. So we're just going to show off some of the other stuff you can do with 3D printing. Now, this first one is actually a metal 3D printer. You can actually 3D print with metal filament and just metal in general. So because metal, it's a lot stronger than the plastics we've been using, you need a lot more heat to actually melt the pieces together. So they're actually using lasers. This is a metal 3D printer at NIAR, or the National Institute for Aviation Research. They have a lot of high-tech polymer labs and 3D printing labs up there. They have some of the coolest stuff in the state.
That is cool.
And I believe they are based at WSU. So
Mhm.
they're great. They have a lot of cool technology there. So that's one of their 3D printers in metal.
Oh, that's neat.
This next one's actually a bit of a different one. This is a concrete printer. This is actually a printer the size of a small house like this. And they can rapidly produce the walls and the foundations of a house like this, just using a 3D printer. And
That is so cool. I
it
love
takes a lot of people to man, but
Yeah, they're building tiny houses.
they're building tiny houses. And I think it said this house could cost about $4,000,
Mhm.
which, I mean, that is cheaper than a used car. That is
Yeah.
extremely cheap. I mean,
Yep.
Oh, and we're moving on
We're moving
to
on.
our bodily parts. So this is actually another metal 3D printer using a laser and a sintering process, a very advanced type of 3D printing. And they're creating actual bone structures that they're going to replace in a patient's bones who I believe had bone cancer.
Mm.
So there might be infected parts of like a kneecap right here or a bone. They'll actually go in and replace that with a 3D printed object.
I love
And
it.
let it heal, let it grow over. It saves a lot of lives, and of course, it's cheaper than traditional, hand-created
Right.
implants. You can create these in a few
Right.
hours and just.
I know
implement
since
them.
the advent of 3D printing, it's just there's been so many examples where it can be a lot more efficient and inexpensive to create your own, to repair your own, rather than to go and buy something new. I mean, I know if I had one of these, I would probably waste so much time building things that I don't need.
It's very
Or
addicting.
just making my own stuff rather than running out to Target to get it, just because it's super fun. I get like entranced by watching these things work. Like there's so like if you get on YouTube and look at those time lapse videos, they're just so fun to watch,
And
I love it.
There's websites out there that
Mhm.
basically already have a compiled, created list of things you can 3D print.
Mhm.
So if you don't want to do the 3D design process, if you don't want to do the CAD because it looks hard, and it can be hard, you can actually just go online and download a file
Mhm.
and instantly 3D print it.
Yep.
So you
Yep,
can
there's
actually skip the
tons-
CAD programs.
Tons of free resources out there. The internet is amazing. And the reason I'm looking over here, guys, is because I'm seeing some questions pop up. A vase. That's a good one, because then you're dealing with different other kind of materials as well.
You can create regular plastic vases for like decorations,
Mhm.
or if you really want to, you could create one out of a wood filament. They actually have filaments they're kind of like a little wood paste that you can use to create, and you can actually sand them and paint them a lot better than plastics. It's just really cool.
I love this one. Someone said a castle, and that kind of leads into our next question of how large can a print get. I mean, if we're building tiny houses out of concrete, I mean, I guess you could argue that you could end up building like a 3D printed castle.
If you want an entire castle, if you had a big enough concrete 3D printer, and they're kind of rare, but they're out there. People can create like castles, and you can also always create like little scale castles in a regular 3D printer as well.
Exactly. So I think people are also going to know, since we're talking about industry kind of things with this and education, what kind of jobs are there out there having to do with 3D printing right now?
So if you want to get a job using a 3D printer, there's actually not that many out there that are solely for 3D printers.
Right.
Most of them are just incorporated into more engineering design process jobs. So if you're thinking about being like a mechanical engineer or aviation engineer or any hands-on engineer, you might use the 3D printer once in a while to kind of prototype a piece and see how well it fits with other pieces. You do that because it's a lot cheaper than actually, milling out or creating a legitimate part out of metal or anything else.
Right.
You would use a 3D printer just to test the fit and functionality of parts.
And I know there's a lot of different kinds of 3D printers, but how much roughly do you think this one would cost you if you bought a new one?
So this one is a Dremel 3040. It cost about $1,500 to $1,600, so $1,500, and that's not too bad for a nice, high quality, self-made, pre-assembled printer like this. But you can get printers as cheap as $100 if you want to put the love and the tears into making it, improving it, and making it even better.
We are going to move on in a second, but I want you to tell the story of this guy too.
Yes, so
I don't think you did yet.
this is one of our functional 3D prints right here. It's actually a little torque ratchet rated for 3 inch-pounds. What this is, this design, this 3D object was created by NASA itself, the guys who go to space and land on the moon, for one of their astronauts in the International Space Station. they actually had a tool. They needed a tool on the International Space Station, and they either didn't have one or they broke an existing tool. And instead of just sending a rocket full of tools, they actually sent this file and 3D printed it online or in the International
That's
Space
really cool.
Station, so they could have the tool.
I mean, that's a great usage of 3D printing. I mean, if you accidentally leave your tool on Earth when you're in
on the
space,
moon.
you can't just say, "Oh, I got to turn around. I left something at home." You
Yeah, I don't want to be that forgetful. I'll
you
talk to you,
either
buddy.
have to make it, or, you have to sink or swim. So that's one of those really cool usages of that, and that's the exact file that was used from NASA. So we reinvented
Yeah, you
what
can
NASA
find it
made.
online.
It's really neat. So Noah, thank you so much. We're going to get to some of those more questions that I see in there in just a moment, but we're going to go ahead and transition to the opposite kind of technology. So thank you, Noah. We'll have you
thank you
back
very
on
much.
later, I'm sure.
Yeah, see you guys in a second.
Yeah. All right, so Noah has shown us, once again, additive manufacturing, and that means it's the part of advanced manufacturing where we're adding to it. So we're taking this filament roll and just making something out of nothing, basically. So we're adding it up. Levi is going to show us the opposite kind of technology. That's going to be subtractive manufacturing. So, you think about what the opposite of that would be. We're taking gigantic pieces of material, big pieces of wood and metal, and instead of building it up, we're shaving it down into the shape that we want. Okay, so this machine does the opposite of what this machine does, and I will go ahead and have Levi come on and show us what she got to show us.
Awesome. Thank you, Lauren.
Mm-hmm.
Well, like she was saying, I'm going to show you the subtractive manufacturing side of what we're doing here today. Now, additive, like we just saw with the 3D printer, just a quick refresher, it's when we take and we have nothing at the beginning and we slowly layer things on top of each other until we've created an object from scratch. So subtractive manufacturing is going to be a little bit more common. It's what you're going to see in more like the manufacturing fields, people making stuff in mass production, usually. We're going to start with a big chunk of material. We're going to slowly take material away from that until we have what we need. And to show you a little illustration of that, I'm going to have Greg go to camera 3 and show you the video of the marble. All right, so this is subtractive manufacturing in action. So this is a sculptor, and he's going to make a really, really cool little sculpture out of marble. Now you can see he started with a big chunk, and he's going to slowly chip away until he actually has the exact shape that he wants. This is the old school way of doing things. It takes a little bit longer, and people mess up, right? So he could accidentally break something he didn't want to break, or just a bunch of stuff can happen that we don't really want. So the way that we kind of got around these issues is we created machines that can do all this for us. Now, machines are a lot faster, they're more efficient, and they don't really make mistakes as often as us humans do. We're going to watch him finish off that little sculpture. So he started with a block, and he's slowly taking it away. Awesome. Now we're going to go back to camera 1. Okay. So to demonstrate this a little bit further, we have the guitar that I already showed you. And I've just got to say, that is so cool. I think I need another one of those. So thank you again, Noah. All right. So now let's think about how they would go about making a guitar like this. This is a piece of wood. That top is made out of maple. The bottom is a piece of what's called jabone wood. And this is also maple. Now, what are the chances that you're going to walk into a forest and find a tree shaped exactly like that? Probably not very good, right? So what we're going to do is we're going to take a big slab of wood and we're going to put it into a machine. We're going to cut away what we need from it, right? And that's going to be a lot faster and more accurate than doing it by hand. Something else that you can do with technology, I'm just now realizing, this guitar is actually Eddie Van Halen's signature model, or it's a copy of his, more or less. They took a 3D picture of the neck of his guitar that had been worn down over tons of years of playing and a lot of shows. It was the perfect shape because wherever his hand was getting in the way, it had worn the wood down. They took a 3D image of that neck, and they used a machine just like this to actually make that neck on this guitar exactly the same as his. It's almost a complete replica. So it's very, very close to the real thing. You couldn't achieve that kind of accuracy by doing it by hand. So we're going to show off our CNC machine that can help us do these things. So we're going to go over to camera 2. All right. Now this is our Carby. It's a little CNC machine. We love it. So to run through the parts that we have here, this is a lot like the extruder on the 3D printer, except we have a drill bit here. So what we're going to do instead of taking a print plate and building up material from nothing, we're going to start with our material on the plate, and this is going to come down and cut away what we don't want, much like we just saw that guy do with the marble, and much like they would do making a guitar. So to do that, the same thing kind of happens as we did on the 3D printer. To move around, this bed goes forward and backwards. That's one of our axes. This moves back and forth to help move that drill bit, and then it goes up and down as well. So you see we have 3 different axes that we're doing here. They also have 5-axis 3D printers that can rotate and go all the way around. That's more like what they would use when they're making that guitar. So we put our material in, and we tell exactly what we want to do on the computer, and I'm going to show you that in a second. Whatever we tell it to do, it's going to do it exactly as we say. It's going to be super accurate, super efficient, and it's going to be a lot faster than doing it by hand. So this is a machine. It doesn't speak English. A lot of us don't speak computer code. So how do we actually communicate with this machine? Well, if I could have Greg go over to our software, I'm going to show you how we do that. Okay, so this is Easel. Now this is how we actually talk to our little carving machine here. So over here, this is something that I've previously made. It's our logo right here, our Future Maker Mobile Learning Lab. Now everything that you see on this is an instruction for the machine. So these dark black lines right here are where the machine is going to cut all the way through the material. Anywhere that you see gray, it's only going to go about halfway through. That's going to leave it white. So this, again, is the instructions. Over here, this is what it's actually going to look like once it comes out of the machine. It's called our preview. So the way I go about making something like this, we have our draw tool right here. Say I want to start a cut right there. I'm going to tell the machine to cut 2 inches, which is 2 of those squares, in that direction. We're going to make a rectangle. All right, so you see when I did that, another rectangle popped up over here. That's because I just told the machine to cut that out right there, and it's going to follow along and cut it out in the real world. So you can do tons of stuff with this. Now, it's also worth pointing out, this is really not that hard to use. You don't have to be fluent in computer code or programming to use a machine like this. They've taken things that are really complicated and they've kind of simplified them so that we can all use them. So I've actually gone ahead and cut this out already. If I could have Greg show that video of our time lapse, we can kind of observe. Right, so this is that exact same nameplate that I was showing you. And while this is going, we can probably come on and we might answer some questions.
Yeah, this takes a little bit.
Yep.
Yeah, so I think you already kind of answered this, but someone did ask if you need to know how to program to basically operate in either one of these, but it sounds like it's not all that necessary.
Yeah, that's a very, very important part too. Because if this stuff was super complicated to use, it'd be kind of tough to get into, but really anybody can do this stuff. In fact, this specific software is called Easel. It's by Inventables. If you go to Google and look that up, you can actually do all of these things yourself. It's a free software and it'll run on pretty much anybody's computer. So you can go around and mess with this stuff.
Once again, with those internet resources,
Yep.
there's so much free stuff out there, folks, that you can go and find. You can find files that you can and make whatever you want to when it comes to this kind of stuff. So I'm curious, Levi, what the coolest thing that you've ever seen made with something like this.
So this is actually really awesome, and I learned about it last week. Some of you guys may know what the International Space Station is. It's a space station that's orbiting the Earth right now. So it's actually going around us as we speak. The rockets they use to send people to that space station have CNC machines that make their parts. So the Falcon 9 Heavy, which is the one that they just sent people in, the body panels for that are actually CNC made, right? Those huge, they're massive, really, really big. They do that with these. So the issue they have is that for every pound that their spacecraft weighs is more fuel that they have to actually push it up into space. So they have to cut chunks of that material out just right so that it doesn't weaken it too much, but it relieves a lot of weight because they're removing material. So to get that kind of insane accuracy, they use these CNC machines.
That's really cool. Yeah. More space stuff, more advanced manufacturing in space.
For sure.
It looks like you've got your plaque finished there that you made.
Yep. So they were pulling it out of the machine. We have all that dust from the plastic.
Yeah, these things get pretty dirty, don't they?
Yep. That will get anywhere and everywhere.
And
All right, if we could
You
go
can
back
even-
to camera 1. Yeah. Alrighty. So here is our plaque. So this is the exact same thing that I just showed you how to make. So you can see we took something, we thought it up, we drew it in the digital world, and we used the machine to bring it into our world, and we actually made it in real life.
Mhm. I am going to catch up on this chat box here. Oh, that's a good question. Someone asked if we can learn this stuff while you're still in high school.
That's excellent. So you guys actually have a very unique opportunity if you're living in the state of Kansas. Now, this may be a couple years down the road, but it's never too early to start thinking about these things. Right now, we're filming this at WSU Tech in Northeast Wichita. They've been very gracious to us. They allowed us this space. They actually will teach certifications, and you can get degrees in this kind of stuff. And the state of Kansas has said that if you want to come take these classes while you're in high school, they'll give you free or reduced tuition to do so because they really need people in these fields. It's a crazy opportunity, guys. I would really encourage you to go look into that. Even if you think it's something you may not want to do, I would look into it.
There's lots of other.
Yes,
It's
there's
not
tons.
just this. Career
Mhm.
technical education is going to span all kinds of stuff. You've got healthcare, you've
Mhm.
got aviation, just welding. There's a bunch. There's a whole bunch.
Yeah, there's more than you could ever know. So I would
Right.
encourage you to go look at it because there may be some stuff on there that you really like, and you can do it for free. I really wish I would have done that when I was in
Me
high school.
too. That would have been cool. We didn't. I think we need to talk more a little bit about. Oh, because we talked about materials over
Yep.
here on 3D printing, but really, if you can think of the material you want to use, there's not much you can't do with
Right.
the Carvey, right? Or
So-
with CNC in general.
Right. So for this specific CNC machine, we use plastic, we use wood. You can even use aluminum with a special bit. They actually have different variations of a CNC machine that would be used to cut different things. For example, you could take off that little drill bit that's in there, and you could replace it with a water jet. Now it's going to be a little different machine. There's going to be a pool underneath, but you can use that to cut through solid steel and really, really hard stuff. You can do the same thing with wood and actually engrave into it. So they take the drill bit off, and you can put a laser that etches and burns into wood and metal and creates like artistic looking stuff.
Yeah, there's some really cool stuff out there. You see artists using this kind of stuff because remember, art isn't just about wall hangings and stuff. You see people making these big, neat wooden and
Mhm.
marble and metal sculptures and making art installations. So you really see a cool intersection of using this stuff for industry and business kind of stuff, but also using it to make like art pieces. So I really like that part about this. And also, you know what? I realized we glazed right over telling them what CNC stands for.
Yeah,
Like,
so-
why-
So CNC is computer numeric controlled. So these are oftentimes referred to as CNC machines, but this is really only one type of CNC machine. So anything that's computer numeric controlled that we're talking to through the computer is going to be called CNC. So in a way, this 3D printer is actually a CNC machine as well. This one is just used for cutting. But this is the one that when you hear people say a CNC machine, this is most of the time what they're going to be referring to.
So another activity that you folks who are watching can think about is if you want to get up and stretch your legs for a minute, we were going to take a few minutes to give you guys, if you see something around your house that was most probably made with a machine like this, basically that means if it wasn't handmade, like if it looks like it was made with real precision cutting, probably made by a machine, look around your house, and as you're able to and as you're allowed to go and pick things up and make sure your grown-ups are okay with you just going and picking something up that might be breakable, you can pick it up, look at it, look at how precise it is, maybe bring it back and hang on to it for the rest of the show, and you can I think that we're gonna Shay's got something for us here. Is this something that was
Can be.
good.
So
Yeah.
yeah, this can definitely be made.
Shay
out
had
of
an example for us. Yeah, so you can kind of bring it back. So Shay's got a tool here, and yeah, this is definitely something that was made with a machine. So all kinds of tools. There's toys, there's chairs, there's furniture, there's all kinds of stuff, and it's really neat to have handmade things. I love handmade stuff, but the truth is, a lot of times most companies can't keep up with the amount of demand that customers have.
And
So-
something else that goes along with that, we can make things a lot cheaper. And kind of like how they were showing you how they can use the concrete houses to attain affordable housing.
Mhm.
Same thing happens with like that guitar right there. Now, you may have heard of a Gibson Les Paul. It's one of the more famous guitars in the world. They have a custom shop where they manufacture all those by hand. It's all handmade. That takes them a lot longer. And those guitars can cost upwards of $7,000-$8,000 a piece. They're crazy.
Yeah.
That guitar right there cost me about $350 because it was made on a machine. So that was much more accessible just
Yeah.
because it was machine made.
Yep, that way you can get a lot more people who can afford those kinds of things.
For sure.
And, oh, that's a good question. Is a lathe a CNC
So,
machine?
a
And
lathe-
what does it do?
So a lathe could be a CNC machine, but it may not. So for it to be a CNC machine, it would have to have an automated little cutter that's computer controlled that goes in and cuts. So a lathe, a little more backstory, it just spins something really, really fast, and you take a blade and you can carve it off that way. Now, a normal lathe would not be a CNC machine because you would take the blade in your hand and you would cut that way. Now, we could have an automated one that does kind of the same thing as this, and it would bring in a little blade with a computer. It's a little bit more precise and accurate. Good question.
I keep thinking about, because my husband and I, we run a piano repair and moving business, and I've seen a lot of really neat YouTube videos and stuff like that where they show machining and manufacturing of pianos. And you know, you get the really, 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 really high-end expensive stuff that's completely handmade, carving and that, you know, carving the wood into the shape of the grand piano. But you know, you also have tons of factories that make more affordable pianos, you know, en masse. And there's a ton, and that's a really big thing too. So like we guys both talked about car parts being made with stuff like this. So you can do very small, you can do very large. Really, the possibilities are so endless when it comes to advanced manufacturing, and it makes things a lot more available to people. It's very helpful to people. But yeah, if you can think of it, I think you said it earlier. If you can, if your imagination goes there, it can probably be made.
And that's something that I was actually going to talk about too. So really the underlying theme of today, like she was saying, if you can think it, you can do it, and don't let anybody tell you it's impossible.
Right.
These machines, we might even talk about later, they get kind of pricey, right?
Yeah. I was going to ask you about that too, about how much this one is.
Yes. So this one's actually $2,500. It's like everything
So
else.
a little
it's
more
range.
than this guy.
Yeah, this one costs a little more. Generally, these probably will. These can get really expensive though, because they get big. So you can have CNC machines that are the size of a living room. Those get like $100,000. So my cousins, they didn't want to spend $30,000 on a CNC machine, but they're very, very smart, and they didn't let anybody tell them no. So they actually made a CNC machine in their garage out of wood. The only part that they kept from a real CNC machine was the motor and the parts that help move it back and forth. Everything else they built, like the supports, were all made out of wood and everything like that, the table. And they got it for very, very cheap doing it that way, just because they didn't take no for an
I have
answer.
this mental picture of a wooden CNC machine. I need to come out and
It
see
is
that
quite a
sometime.
sight.
That's really neat. That's awesome. Yeah, and so now we're doubling down on this idea of making your own, because now you can make the machine that makes your own thing. We're just not going to need stores anymore.
Exactly. And even like Noah was saying with the 3D printing earlier, he takes and he 3D prints parts for his 3D printer. So you can customize things like crazy. It's very cool.
Creative minds out there can really go nuts with this kind of stuff.
Absolutely.
So, yeah. All right, well, Levi, we touched on jobs a little bit too, I think, didn't we?
So this one actually, there are jobs for just being a CNC operator.
Right.
You're going to make about $30,000-$40,000 a year. Much more common though is anybody in manufacturing is probably going to have some experience with this in the future, just for making their job a little bit easier and more efficient. So if you're in the auto industry, if you're making airplanes, if you're making furniture and using like or a laser engraver and stuff like that on CNC, you're going to be dealing with these machines most likely in the future.
That's really cool. Yeah, and this one's actually a lot heavier too.
Yes.
This one's, it took both of us to get to hoist that up onto the
For sure.
table.
It's about 67
Yeah,
pounds.
so once again, folks out there who are watching, do not try to operate these or lift them without adult supervision. They can be dangerous. So, Levi, thank you so much. I'm going to answer a few more questions that I'm seeing up there, and if I think of anything else, I'll pull you back in.
Awesome.
So,
Thank you.
Thank you, Levi, for showing this off to us. Not seeing anything else here. So, what I was going to get more into now, thank you so much again, Noah and Levi, for showing us these two different kinds of technologies. This is really excellent. Really, really cool. Your imagination, you can go nuts with how much you can do with these things and all the possibilities that are out there. So careers in modern manufacturing. This is, if you like he said, if you don't think that you would want to do this kind of thing exactly, there is so much more to it that you could do as well. There are careers in aviation, there are careers in welding, there are careers in healthcare, like I said, and Levi already started talking about this a little bit, but one of the things that Future Maker goes out and does, one of the main reasons that we go out and talk to students around the state of Kansas and out in the community here, is the fact that from the time you're a junior in high school, you can go to your local technical college and start getting education in a field like this. Maybe not a field, maybe not CNC, but some sort of field in the career technical education side for free tuition from the time you're in 11th grade on. And so ultimately what happens is that we end up having students who started taking college classes while they were still in high school, and they end up graduating with a 1-year certificate in something or a 2-year associate's degree at the same time that they graduated high school, and then they can immediately go out and get a job. So if you don't think that a 4-year university option is quite for you, you can take college courses for free in the state of Kansas, whether it's here at WSU Tech, which is where we operate out of, or if it's somewhere else like Hutchinson Community College or one of those other places. So that's a really big deal, and a lot of people don't know about it. And so that's one of the reasons why we exist, is to go out and spread the word. So it is never too early to go and talk to your grown-ups, to your high school advisors and counselors, to your teachers, if you would like to do these kinds of things. And I know one of the reasons you're here today is so that you can learn a lot more about science and technology, engineering, and math careers. And we're here to let you know that there are a lot more women in these fields than there used to be, and it's just growing. What you have happening right now is there are a lot of retirement age people leaving these fields, and so we need lots and lots of workers, and that's going to end up including a lot more women in these jobs. So you're likely to be able to go out there and find scholarships that are geared toward attracting girls and women into these fields. So lots of opportunity for free and reduced tuition. Talk, like I said, it's never too early to talk to the grown-ups in your life who can talk to you more about this. So if you want to learn more about these kinds of queries, you can go to the website of your local technical college, whether it's WSU Tech or otherwise. You can find out about all the different programs that are offered for that free and reduced cost. So anyway, I think that we are at about time, and I don't see any more. Oh, I see a couple more questions here. Oh, that's really good. Can a 3D printer and CNC be used together? That would be interesting. If Levi, you want to come back on.
So again, guys, like I was saying before, if you can think it, you can do it. Absolutely, they can be used together. You can make something on a 3D printer, and then you can carve away at it.
Right, that's true. You could make the thing. I didn't even think about that. That's a good question. You can make the thing, and if you decided that it needed a little bit more touch-ups here and there with precision, you could put it in the carving machine and do that. That's a really good question. That's really neat. Yeah, possibilities are. Noah, did you have something to add as well?
Yeah, I mean, let me step in right here. I mean, the more varied tool, the more variety of tools you use, the more creative your object can be. So 3D printers always have something that they can do better than a carving, but the carving may be able to do something better or can do something that the 3D printer can't. So if you combine the best of both worlds, you can make some really cool stuff doing this.
That's really neat. Thank you. Okay, and can I print a 3D object in 2 parts? Excellent. This will be probably our last question.
Yes.
But I think the Darth Vader head is a good example of that, right? Because doesn't this guy pop off? Yep, it does.
Yep.
So you can see I've got these 2 parts here. This is just his the base and his head, and then his helmet is a separate part. So
multi-part prints are everywhere for a few reasons. Say if you want to build something that's bigger than the actual build plate or the surface area in this printer, well, you can make it into 2 parts and add them together at the very end. Or if you have a very complex like machine type thing, lots of little screws or springs or jigs or whatever, you can make all those tiny little parts and assemble them just like a little kit into something fully creative.
That's so neat. I'd have so much fun if I had one of these. Thank you, Noah.
Yeah, of course. Any other questions?
I think that we're good. I think we're good. And I think we're at about time. So I just wanted to thank once again my co-hosts Noah and Levi. You have given us so much neat information. I hope that you at home have taken away some good stuff from this and can just go and let your imaginations run wild and look at more of this stuff on the internet for yourselves. Once again, that tinkercad.com website is free and you can design things. Even if you don't have a 3D printer, it's fun to get in there and look at what you can build. So thank you, my co-hosts. Thank you, Shay and Greg, for operating all of this for us, and thank you to both WSU Tech for making sure that we can have this digital content lab to come to you today. And thank you, WSU, for hosting us, for expanding your horizons. And thank you guys. You've been a great audience. You've asked some great questions. I know that thank you. Make sure and stay curious. There's lots of stuff out there to learn, and make sure you talk to your grown-ups and your teachers and your advisors about everything you can do in career technical education. And hopefully we can come out someday and see you in person with our actual mobile learning lab once this is all over. But until then, we're happy to come to you virtually. So thank you so much, everybody. Have a great day.